Comparing fractions. Just like with whole numbers, we can use the symbols less than, greater than, and equal to compare fractions. But sometimes it's difficult to decide which fraction is greater. Here are some tips to help. If the fractions have the same denominator, like 5/8 and 6/8, look at the numerators. The bigger the numerator, the bigger the fraction. That's because the size of the piece is the same for both fractions. We're dealing with eighths. But if the numerator is bigger, that means I have more pieces. Take a look at the pictures. On the left, you see 5/8, and on the right, 6/8. If you think about this like a cake, we have two cakes that are both cut into 8 pieces. So all of the pieces are the same size. But on the left, I only have 5 pieces of cake, and on the right, I have 6 pieces of cake. 6/8 is greater than 5/8. If the fractions have the same numerator, like 5/8 and 5/6, look at the denominators. The bigger the denominator, the smaller the fraction. This is sort of backwards from what you might think. Let's take a look at a picture of 5/8 and a picture of 5/6. This time, if we think about them like cake, one of my cakes is cut into 8 slices, and the other cake is only cut into 6 slices. That means each of the 6 slices is bigger. I have 5 pieces of a cake cut into eighths, or 5 smaller pieces, compared to 5 pieces of a cake cut into sixths, 5 bigger pieces of cake. 5/6 is greater than 5/8 because sixths are bigger than eighths. If the numerators and denominators are both different, there's a few different strategies we can try. Let's compare 4/10 and 1/2. Sometimes it's helpful to compare to a benchmark fraction. A benchmark fraction is just a fraction that's easy to visualize, like 1/2. You can clearly see what 1/2 looks like when you think about it. When we think about 4/10, we should realize that 5/10 would be equal to 1/2. 4/10 needs another tenth more to equal 1/2. If we take a look at a picture of 4/10 and a picture of 1/2, we can see that 4/10 needs one more tenth. Now it's equal to 1/2, but we are missing that tenth. So it is a little bit less than 1/2. Let's try comparing 7/8 and 5/6. Sometimes comparing a missing piece is easier than comparing what's there. If a fraction is missing more, that means it's a smaller fraction. Take a look at 7/8. It's almost all the way colored in. It just needs one more little eighth to be one whole. If we look at 5/6, it's almost colored in too, but the piece that is missing, the white, is bigger than with 7/8. That means 5/6 is smaller. 7/8 is only missing one little eighth. 5/6 is missing a bigger piece. It's missing a sixth. 7/8 is closer to one whole. It's missing less, so it is a bigger fraction. Another strategy you can try if the numerators and denominators are both different, like 2/3 and 3/4, you can always try drawing a picture of each fraction. Sometimes this helps, but when you draw fractions, you have to be very neat and exact. If your drawing is messy, you won't really be able to use it to help you. It might even lead you to the wrong answer. So when I draw 2/3 and 3/4, I start by drawing a bar, like this. And then, because I'm drawing 2/3, I need to try to divide this bar into 3 even pieces, which can be kind of tricky. Just do your best. Remember, each piece should be the same size. And then I would shade in 2 of them because I'm drawing 2/3. When I go to draw 3/4, I need to draw my bar the same size as I did for 2/3, like this. Except this time I'm dividing it into 4 even pieces. And fourths are actually easier than thirds. A good way to do fourths is to divide it in half, and then divide each half in half. And I'm looking at 3/4, so I will shade in 3 of them. When I look at these two pictures, I can see that 3/4 has more shaded in. 3/4 is greater than 2/3. Let's try comparing 2/3 and 3/5. Sometimes a picture won't help. You may need to create equivalent fractions with the same denominator. Let's look at a picture of 2/3 and a picture of 3/5. They are so close, it's hard to tell which has more shaded in. So let's look at how we can create equivalent fractions with the same denominator to make it easier to compare. The first thing we're going to do is multiply the denominators together to create a common denominator, or to make them both have the same denominator. So we're going to multiply the denominators 3 and 5. 3 times 5 is 15. Now let's set up equivalent fractions that both have 15 as a denominator. Now multiply to find the new numerators, like this. 3 times 5 is 15. So if I want to create a fraction that's equivalent to 2/3, I have to do the same to the numerator. 2 times 5 is 10. Now let's do 3/5. 5 times 3 is 15. So if I want this new fraction to be equivalent to 3/5, I have to do the same to the top. 3 times 3 is 9. So 2/3 is equivalent to 10/15, and 3/5 is equivalent to 9/15. Now I can easily compare because they have the same denominator. 10/15 is bigger than 9/15, only by 1 little 15th. A shortcut strategy for this is called the fraction butterfly. Let's look at that strategy now. The first thing we're going to do is multiply the denominators. 3 times 5 is 15, and that will be the new denominator for both equivalent fractions. Then you're going to multiply to form butterfly wings, like this. And I think about it like this. 3 times 3 is 9. That comes out the top of the butterfly wing and over to the right to create 9/15. Create another butterfly wing. That's 5 times 2, and that is 10. It comes out the top of the wing and over. 2/3 is equivalent to 10/15. Now we can easily compare. 10/15 is greater than 9/15, so 2/3 is greater than 3/5. Let's try one more using the butterfly strategy to create a common denominator. So remember the steps. First, we multiply the denominators together. 10 times 6 is 60. Then we multiply to form butterfly wings. 10 times 4 is 40. 6 times 7 is 42. Now, instead of comparing 7/10 and 4/6, I'm comparing 42/60 and 40/60. 42/60 is greater than 40/60, so 7/10 is greater than 4/6. Reminders. If the denominators are the same, compare the numerators. The bigger the numerator, the bigger the fraction. If the numerators are the same, compare the denominators. The bigger the denominator, the smaller the fraction. If the numerators and denominators are both different, there's a few things you can do. You can compare to a benchmark fraction like 1/2. You can compare the missing piece. You can try drawing a picture of each fraction, Or you can create a common denominator. Try using the shortcut butterfly method.